Good morning, student of class 10th. We were doing real numbers exercise 1.1. We have done question number 1 and 2. Question number 3. Saying an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of column in which they can march? So he is asking the maximum number of columns. So we have to find SCF. SCF of 616 and 32. Question number 3. SCF of 616 and 32. Since 616 is greater than 32, now using Euclid division lemma, (616) is equal to 32 into, we have to find 32 into 9. Because 10 times it will be 20. And to the 90 to the 38, 8, 3 carry on, 93 is 57 or 3, 60. So 608, remaining will be 8, means 19 times and remainder 8. Now again 6, since 32 is greater than 8, therefore 32 is equal to 8 into 8 for the 32 plus 0. Now SCF will be 8, remainder 0, so SCF 8. Now question number 4. Use Euclid division lemma to show that the square of any positive integer is either the form of 3m or 3m plus 1. Let a be a positive integer and b is equal to 3. Now integers for that a is equal to bq plus bq, b our 3, so 3q plus r, where r is greater or equal to 0, less than 3. So now integers (3q plus 0), (3q plus 1), or 3q plus 2. So case 1, when a is equal to 3q plus 0 or 3q, and on squaring both sides, a square is equal to 3q whole square. On squaring both sides, so a square is equal to 9q square, or a square is equal to 3 into 3q. This implies a is equal to 3m, where m is equal to 3q. Case 2, second, a is equal to 3q plus 1. Again on squaring both sides, a square is equal to 3q plus 1 whole square. On squaring, so a square is equal to 9q square plus 2ab, so 6q plus 1. We can write a square is equal to, take 3 common, inside will be 3q square plus 2q plus 1. This implies 3m plus 1, where m is equal to 3q square plus 2q. Case 3. A is equal to 3q plus 2. Again on squaring both sides, so a square is equal to, do directly square here on squaring. A square is equal to 9q square plus, it is a 6 to the 12, q square plus 2 square 4. Now a square is equal to 3 sorry, here 2ab 12q. So we will take 3 common, inside will be 3q square plus 3 4s are 12, so 4q plus 1 and outside also 1. So a square will be 3m plus 1, where m is equal to 3q square plus 4q plus 1. This one. There was this one. So now we can see the square of any positive integer is in the form of 3m or 3m plus 1. Thus, square of any positive integer is either the form of 3m or 3m plus 1. Clear? Same as question number 5 you will do, same as question number 4. In question number 5 you will do on cubing both sides and process will be same. Clear? So in next video we will start next exercise. Thank you guys.